I will just request the audience to maintain silence throughout the proceedings and not to take photographs during the talk. And kindly switch off all the mobile phones. Just to let you know that after Professor C.N.R. Rao's talk, there will be an interaction session in which you can interact with him, ask questions, clarify your doubts, ask pretty much anything that you like. Bharat Ratna, Professor C.N.R. Rao, Professor Gautam Biswas, Director, IITGuwahati, students from schools, colleges, and universities from in and around Guwahati, coordinating teachers, students from the campus, faculty and staff colleagues, students from IITGuwahati, ladies and gentlemen, a very warm welcome on a nice morning here at IITGuwahati. The morning is a little wet and gloomy, but I'm sure that's going to be undone by Professor Rao's talk. I'll give a brief introduction of the event. So today we are gathered here to listen to a popular science lecture titled Celebration of Science by Bharat Ratna Professor C.N.R. Rao. So what's a popular lecture? Why is it given? Scientific knowledge is of use for everyone. So we know how our day-to-day life is influenced by science. Thus, popularization of science is an essential endeavor to disseminate scientific ideas to everyone, particularly to the non-specialists and who aspire to take science as a career, so that the fundamental concepts of science can be promulgated. We are truly fortunate to have Bharat Ratna Professor C.N.R. Rao with us, who has been associated with science education and direct contact programs with school children for a long time, and his untiring efforts of popularizing science have ignited several young minds across the country, spanning several decades. Mormor Chhatra Chhatri Hokolak Azir ei Karjosuchir Pabe Bishesh Pabe Aruni Janami. Now I'll give a brief introduction of the speaker, Professor C.N.R. Rao. It's very difficult to do it in a time-bound environment, but I'll still try my best. Professor C.N.R. Rao doesn't really need an introduction to the audience present here. However, I feel extremely privileged to have the opportunity of presenting to you some of his remarkable achievements. Professor Rao was awarded PhD degree from Purdue University, USA in the year 1958. Subsequently, he was awarded BSc degree, Doctor of Science, from Mysore University in 1960. He is the recipient of honorary BSc degrees from over 60 international and national universities. Prior to establishing the Solid State Structural Chemistry Unit and the Materials Research Labs during 1977 to 84, he was a professor of chemistry at IIT Kanpur from 1963 to 1976. Professor Rao was the director of Indian Institute of Science, IISc, during 1984 to 1994. And he was also the president of JNC ASR, Jawaharlal Nehru Center for Advanced Scientific Research, during 1989 to 99. He is currently the National Research Professor and Linus Pauling Professor at the JNC ASR. Professor Rao is a fellow of a large number of institutions and academic bodies in India and across the world. Just a few names from the list include Royal Society of London, National Academy of Sciences, USA, Japan Academy, and Third World Academy of Sciences, TOAS. Professor Rao is also the recipient of a large list of awards and honors. To name a very few of them of the national awards: Bhatnagar Prize, 1968, S.N. Bose Medal, 1980, Meghnad Saha Medal, 1990, Karnataka Ratna, 2001 is the highest honor of the state of Karnataka. India Science Award 2004, Bharat Ratna, the Jewel of India in 2014. And some of the international ones are Lackett Lectureship from the Royal Society of London in 91, Albert Einstein Gold Medal UNESCO Paris 96, Hughes Medal for Physical Sciences from the Royal Society of London again in 2000, Chemical Pioneer American Institute of Chemists USA 2005, Nikkei Asia Prize for Science, Technology and Innovation from Japan 2008, the August Wilhelm von Hofmann Medal for Outstanding Contributions to Chemistry by the German Chemical Society in 2010, A.D. Little Lecturer in Chemistry, MIT, USA in 2010, Albert Einstein Professor of the Chinese Academy of Sciences, and International Award Gold Medal of the Chinese Academy of Sciences in 2012. Professor Rao's research interests include solid-state structural and materials chemistry with particular focus on transition metal oxides, metal insulator transition, superconductivity, multiferroics, etc. It's published more than 1,600 research articles and 48 books, which we have received more than 70,000 citations. To summarize, Professor Rao is the face of a large and vibrant scientific community of India and is an inspiration to all the students and researchers in and around the world. I will now request Professor C.N.R. Rao and Professor Gautam Biswas to kindly come onto stage. Professor Biswas is requested to felicitate Professor Rao in a traditional Assamese manner. Now I request what you have been waiting for, Professor Rao, to deliver a popular science lecture titled Celebration of Science.
Good morning to all of you. I am very glad to be here in Guwahati to give a lecture to children of schools here. I picked a topic of a general nature, celebration of science. It is a small little story of science. In doing that, I recall how some important things have happened in science. Unfortunately, when we study science in school, our teachers don't tell you the stories of science. They don't show, for example, the pictures of the great scientists who actually made those discoveries. So when you see Rutherford, for example, you don't know how Rutherford looked like. You say Faraday, you don't know who Faraday was. Faraday had long hair or short hair, you don't know. I think it's very important to have one-to-one contact with the scientists who made discoveries. You have to understand the personality of the discoverers, the spirit of those discoveries, to understand the secret of their discoveries. The purpose of education is to improve the creativity or recognize creativity in children. One way of doing that is to try to understand the secret of creativity of great scientists. So it is for that reason I am giving you this lecture called Celebration of Science. You may remember about 6-7 years ago, we celebrated the 200th anniversary of Charles Darwin. I hope your schools told you that. Otherwise, you remember that. Charles Darwin, who gave the theory of evolution. Just 3-4 years ago, we also celebrated the 150th anniversary of a very great, the first modern scientist of India, the first modern physicist of India, J.C. Bose from Calcutta. Unfortunately, no school thought about it. J.C. Bose was the first modern scientist of India because he in Calcutta in 1895, long ago in the 19th century, discovered telegraphy in Calcutta. Don't forget, when he discovered telegraphy in 1895, the electron had not yet been discovered. Electron was discovered only in 1897. In spite of that, this young Bengali scientist made this major discovery for which he should have shared the Nobel Prize with Marconi. For some reason, of course, then India was a colony. He did not have enough influence in science, I guess. Somehow he was not recognized with the Nobel Prize. But what is amazing is that he did make such a discovery right in India long, long ago in the 19th century. But today I'm not going to talk about those things. I'm going to start off with, just pick one arbitrary year. Arbitrary year, I'll pick 2011. 2011 was a very great year because it was a centenary of many things. First of all, it was a centenary, 100th year of the discovery of the atomic structure by Rutherford. I am showing in this picture, in the center is Lord Rutherford. I hope you know what Lord Rutherford was. He is the one who gave the structure of the atom. That is the most important fundamental truth that we have in science. I hope you know, of all the truths of science, of all the knowledge of science, the most important knowledge is that everything in the universe, everything in the world is made of atoms. Therefore, that fundamental truth about atoms you should remember. In fact, Feynman was said, suppose by some calamity, all knowledge is wiped out of the world. I hope one truth will remain that the world, all the things in the world are made of atoms. And those atoms, the structure of that, this gentleman here now, he was the emperor of physics. He was somebody who was unbelievable. Let me tell you a story in 1 minute. At a young age of 18, he came to Cambridge to do a PhD. Did his PhD. When he was doing his PhD, the electron was discovered by J.J. Thomson. J.J. Thomson, when he discovered the electron in 1897, there was Rutherford working with him for a PhD. He was a right atmosphere. Soon, within a few years, he did discovery of disintegration of atoms and so on. He got a Nobel Prize within another 5-6 years. After the Nobel Prize, then he came with this major idea of the structure of the atom. So whenever you think of the atom, it is another third atom you think about it. The nucleus in the center, electrons around it. Before that, J.J. Thomson gives the opposite thing, electrons in the center, nucleus around it. So he corrected the model of the atom given by his own teacher. So the two people next to him are Cockcroft and Walton. Hope you know that. Otherwise, you should know that the first one to build the atom stacking machine, the first Van de Graaff machine, who built that machine because of Rutherford, and both of them got Nobel Prize. Rutherford had this knack to bring a lot of people to his laboratory, young people, and they would all make discoveries. All of them would get Nobel Prize. In fact, Rutherford, if you remember, if you remember the story of the atom, got Chadwick to his laboratory, was doing something somewhere, he discovered the neutron, he got a Nobel Prize. He got Kapitsa from Russia, he is the first one to do experiments at liquid helium temperature, he got another Nobel Prize. Like that. In fact, the joke then was, the taxi drivers in Cambridge, you would ask them, they say, I want to go to Cavendish Lab, where Rutherford is working. They say, no, I won't take you, because if you go there, you will make us do research and get a Nobel Prize. So, taxi driver will give go there. That was a joke. But this was a great man. We need teachers like that. In fact, after his famous discovery of the atom structure, he himself didn't do much work. He let his students do all kinds of things, become famous, and this Rutherford is discovered. We should have celebrated 2011 as the 100th anniversary of the discovery, and for some reason we didn't do that. This is the structure of the Rutherford atom, but I will not talk about it. This is the model we use all the time. And this is the younger Rutherford, where he got a Nobel Prize in 1908 for his investigation of disintegration of elements. And after that, in 1911, 3 years later, after the Nobel Prize, he discovered the structure of the atom. 2011 is another famous thing. It's also centenary of the discovery of superconductivity. I hope you know that. Superconductivity is one of the most important phenomena of materials. It is the most important phenomenon of solids, because in an area where I used to do a lot of research at one time myself. What is superconductivity? A superconducting material is one which loses resistance to passage of electricity at some temperature. It becomes, there is no resistance. But that is not the only thing. It also throws out all the magnetic flux. It literally vomits all the magnetic flux. Therefore, the material becomes diamagnetic. A superconducting transition. First superconducting transition was also discovered in 1911. 2011 therefore was centenary. This is the man who did that. Cameron Gomes, he got a Nobel Prize for doing this work at that time. And this is Cameron Gomes with his teacher, Van der Waals. I hope you know, some of you, Van der Waals interaction, and so on in school, maybe, maybe not. But this is the first transition of mercury becoming superconducting, where the resistance goes to zero, or almost zero, at 4.3 Kelvin. So this is it. We didn't celebrate it, but it so happened to, just took 1 year. You see so many major discoveries in 1 year. And this is a very important picture. The reason it's an important picture is, in 1911, exactly 100 years before that, they decided to invite all the great scientists of the world in Belgium. It is called the Solvay Conference. The first Solvay Conference is a very important historical landmark of science. Because then they decided the future of science, the future of physics, and so on. And every scientist important at the time was there. I hope you can see Madame Curie sitting there, Max Planck there, Rutherford there. Who is this man? Einstein. You see, Einstein is standing there mainly because he was still not so important. You see, in 1911, Einstein still not made major discoveries, so he had to stand there. Okay? And then a few years later, there was another Solvay Conference. In the other Solvay Conference, you see, now where is Einstein? Einstein made major discoveries in 1915, around that period, and he became a very great physicist, well recognized by the year 1927. So Madame Curie is an old woman right now, yeah. There are many others. And I don't think, in fact, I used to give this picture and the other picture to all my undergraduates in my tutorial when I was a professor in IITGuwahati. Identify all the photographs. They would get as many marks as the number of scientists they identified. And that marks are added to their performance. So very few people identified all of them. The work with the professors also didn't know. Nobody knew all the names there. There is a culture. You have to know them because they are the scientists who made what science is today. All of them. Who is that man sitting there? Can you recognize? No, I'm sure. Niels Bohr. Niels Bohr theory of the atom. So Niels Bohr was sitting there, and behind him there is a young man standing there. You know who he is? Heisenberg. I don't think you know who Heisenberg is. Heisenberg was the age of 22. Let me tell you the story of the young Heisenberg. Heisenberg came to work as a project assistant, as a research assistant, under Niels Bohr. He was 22 years old. See, all these people did these discoveries when they were very young. That's why I'm talking to you guys. You must also do that, okay? At the age of 22. I'll tell you more stories of the age of 22, how it is important. This man at the age of 22 started working there. Then one summer, like all European scientists, Niels Bohr goes away on a holiday for 3 weeks. When Niels Bohr comes back, Heisenberg said, Professor, when you were not there, I made a major discovery. Oh, let me see what you have done. Yeah, but I'll show you, but I've already sent it for publication. He said, what do you mean? I was just out for 3 weeks, how can you send it for publication without telling your own professor? Well, no, I think my discovery was so important, I didn't want to wait for anyone. Here is the young boy of 22 telling his big Niels Bohr. And you know what? That was the Heisenberg uncertainty principle, for which he got a Nobel Prize. So that is, there standing that young Heisenberg. So these are all very interesting things to know. The reason I had this was, in 2011, there was in fact a celebration of the centenary of the first Solvay Conference. In fact, I just showed the same picture I've shown you earlier. In fact, I was also one of the speakers in that. I don't know why they invited me, even though I'm a chemist. It was a very nice conference. to celebrate the 100th anniversary of the first Solvay Conference. But 2011 is not over. You know, that is the centenary of Madame Curie. Well, Madame Curie got her second Nobel Prize in 1911. So 2011 was the centenary, and that's what, if you remember, it was celebrated as the International Year of Chemistry. International Year of Chemistry 2011, all over India also, they celebrated it just to celebrate the second Nobel Prize of Madame Curie, who shared that Nobel Prize in Chemistry in 1991. Well, I'm going 1 year later, you see. Oh, I've just picked some arbitrary year. 1912, what's so great about 1912? Well, there is another 22-year-old young man. He's again 22. He's called Lawrence Bragg. Then this 22-year-old man was running around the backs in Cambridge. Backs are nothing but the area behind the colleges in Cambridge, along the river. He used to keep walking around most of the time, I believe, and made a big discovery of X-ray crystallography. How you can solve the structure of crystals using X-rays, X-ray diffraction. Further, he was youngest Nobel Prize winner in the history of Nobel Prizes. At the age of 25, he shared a Nobel Prize with his father for discovering crystallography. What is the power of this discovery? I hope you know that. There have been 15 Nobel Prizes after this for people who have made use of crystallography. The original crystallography discovery was done by him. In fact, even a few weeks ago, I took out that paper he wrote in 1912. My God, how did he write this fantastic paper of solving structure of a crystal, this young boy in 1912? It amazes me. Very, even today, suppose I gave the same thing to a PhD student, he won't be able to do that. It's very, very beautifully done in 1912 by Lawrence Bragg. I hope many of you in school may not remember. There is something called the Bragg equation, n lambda equal to 2d sine theta in X-ray crystallography and so on. They're all due to this Bragg, Lawrence Bragg, a young man who made this discovery in 1912. So as I told you, 2011 we celebrate the International Year of Chemistry to celebrate Madame Curie's second Nobel Prize. So let me spend some time emphasizing more on chemistry today, because I thought I would pick one subject to show how a subject develops in science, how a subject changes with time, how a subject takes over the entire world it belongs to. Well, many people, in fact, I have heard of it, in fact, recently, apparently some ministers in the government said, what is so great about science? What has science done? You know, they talk like that. And somebody I wish had told him this slide. If you go back not to the like 100 years earlier, we didn't have X-rays had just been discovered, radioactivity had just been discovered in 1911, atomic structure was just discovered in 1911, chemical bond was known. There was nothing called a chemical bond. Nobody knew what a chemical compound was in 1911. Diffraction came after that. Most of the DNA was unknown. So in 100 years, the progress made in science is so enormous. It's something unbelievable. In 100 years, it's unbelievable. In fact, we say progress of science. In the last 20 years, more science has been done than the rest of history before that. In 25 years, roughly, or 20 years, roughly the amount of discoveries made by man is more than double the total discoveries made in the rest of the world before. That is how science is progressing. Unfortunately, of course, politicians don't know that. Of course, even scientists don't talk about it. So I wanted to know that why scientists are saying. When I say please include engineering, science includes engineering. Unfortunately, I'm not giving too many engineering examples today. But engineering is actually a science. So the engineers do not say that. Engineering is actually a science, but they think they are engineers and they are also science. Engineering is a science. I think the universities where I come from, whether it's Harvard, or University of California, Berkeley, or Cambridge, engineering is science. I hope you know. Homi Baba, our old Baba, he got a BA in engineering. The engineering degree is called BA in Cambridge, Master of Arts. And then he got a PhD in physics. And then he became a nuclear physicist, right? So how can an engineer become nuclear physicist? That's the thing. That's the thing. Science, there's no difference in engineering, physics, chemistry. We make new discoveries in science, it doesn't matter what. Okay, Baba is a good example. So for you, I'll give you one advice based on that. Science is such a subject, you can become a scientist at any time in your life. You can't say, hey, chemical engineering, sorry, I don't know why I choose Hindi. Why I studied chemical engineering or mechanical engineering, okay, you become a scientist. No. Anybody can be a scientist anytime in life. Don't forget, Linus Pauling, who is my hero, I'll talk about it soon. He was a chemical engineer by nationality. The other great man, Robert Bharat, who got a Nobel Prize in chemistry, whom I was associated long ago. Robert Bharat is dealing as an electrical engineer. So some of the greatest scientists I know have engineering degrees, then switch to science. In fact, some of my very good friends I know today, in my own field, in many other fields I know, they were engineers by training, become scientists. So you can be anything. All you need is a mind that is required to discover new things. So I just want you to know that. So if any of you doesn't matter, you take any degree. Degrees are unimportant. You get B.Tech or M.Tech or MC, MSc, doesn't matter. Later, if you want to make a new discovery or a new idea, you can still do that. I want you to remember that. Okay, coming back to what I was saying, let me tell you a little story of chemistry. Chemistry started in the 18th century. You see, we talk of chemistry as an old subject. Actually, Lavoisier, at the end of the 18th century, he died, and he is the one whom we call the father of chemistry. It's only 200 years then, chemistry has existed as a subject. 17th century, physics got recognized as a subject. Newton decided or determined what physics was in the 17th century. Exactly 100 years later, in the 18th century, Lavoisier described what physics was. In fact, when Lavoisier was there, people didn't know whether water was a compound or not. He was the one who showed water was a compound. He was the one who showed air has oxygen and nitrogen. He was the one who showed conservation of mass. Very, very fundamental to all of science, fundamental to chemistry as well, and he is called the father of chemistry. Unfortunately, the story of Lavoisier is not over. Unfortunately, even though he is such a great scientist, he also had one weakness. It is not a weakness, unfortunately, it became a weakness. He was a very close friend of the king and the queen of France. And at that time, 1794, if you remember, there was the French Revolution. Because the French Revolution of bringing everybody who was close to the king and the queen, they cut off their heads. So they came and severed the head of Lavoisier. They didn't realize what head they had to rule. One of the greatest heads that we had in the world. In fact, afterward they would go on looking for his head. They never found his head. Because with their thousands of heads, they had cut off this French Revolution. So we got the father of chemistry in that way, in the French Revolution. He's the one who decided, who told what chemistry was. Then of course you all know Dalton. The reason I'm showing you is Dalton's atomic theory, even today in schools, ask you, it was when I was also in school, they would ask, what are Dalton's postulates, atomic theory? We all vomited out all the answers. And of course some of it is wrong, but he was a great man. But this is interesting. The idea of an atom, who gave the idea of an atom? Well, even though Indians say, oh, we gave C.N.R, or great saint gave it, Democritus is Greek saint. But the proper understanding of atom, the way we understand today, was actually by Dalton. And Dalton, that was in 1803, just the beginning of the 19th century, just about 200 years ago, he gave the idea of an atom. And the chemist who gave the idea of an atom, physicists didn't accept the idea of an atom for a long time, and eventually they also agreed with the atom. The first idea of an atom came with Dalton. And of course, in the 19th century, the greatest scientist of all time, but yesterday in my lecture I was telling that about Faraday. Let me tell you a few words about him. You have read Faraday's laws of electrolysis. That is all you read in school. Have you read it or not? Yes or no? Yeah, that is nothing. There is only a very small part about Faraday. You see, suppose somebody asks me, pick one name in science to the biggest name in science, greatest name in science. That would be Faraday. I hope at least that you will remember out of my lecture. The greatest scientist that ever lived on earth is Michael Faraday. Nobody can beat his performance. The number of discoveries he made is enormous. He had only had 3 years of schooling. He did no mathematics, but slowly working in the laboratory of Humphrey Davy, he started learning how to do experiments, started doing his own experiments, started publishing his own papers. This is the first one to do laws of electrolysis. Then what else did he do? He was the one who used the word electrode, anode, cathode, electrolysis. All of He is the one who did magnetism, paramagnetism, diamagnetism. What is that? But not a very good sound. But anyway, let me tell you one story. In fact, I hope you all know that oxygen, he used to do very simple experiments. Oxygen is paramagnetic, nitrogen is not paramagnetic. I hope you all know that. Oxygen is magnetic, paramagnetic. Then somebody asked him, how do you prove that? You ask the professor of physics in IIT, well, you go on, and he won't come with an answer. Go to the it's not only IITGuwahati, in India, it's the same process of the country. Because they were thinking, what a very complex experiment, how to do that. Not Faraday. Faraday was a very simple experiment. He took a little magnet in his pocket, little magnet, put it there. He made soap bubbles containing oxygen, soap bubbles containing nitrogen. He made the bubbles go through his magnet. The soap bubbles containing oxygen got stuck to the magnet. The soap bubbles containing nitrogen didn't stick to the magnet. He said, oxygen is paramagnetic. How many will do this experiment? Think of this experiment in this way. They will think of very difficult experiment which they won't be able to do for the next 1 year. Not like that. In fact, he did an experiment called the Faraday. I want to tell you that. It's a very sophisticated experiment which we still use in physics and material science. It is the rotation of the plane of polarization of light when you apply a magnetic field. I tell you, it's extremely difficult to do those experiments. Even today, to make a Faraday rotation in the lab is very difficult. This is work for months and eventually get wrong numbers in there. Faraday did it in a very routine manner. And Professor C.N.R was alive. One of his PhD students, he told him, I want you to measure Faraday effect in some materials, whatever, many different. In fact, the person who did a very close friend of mine, S.N.R. his PhD thesis was Faraday rotation. He had such a difficulty doing those experiments. Very difficult. He was Faraday in 19th century, discovering Faraday effect. How we have this tremendous green thumb to do experiments. Some people have it. You see, this Faraday was. But he also discovered, I hope you all know, electricity. And for discovering electricity, at least he would have got a Nobel Prize. He discovered benzene, the most important molecule of organic chemistry. He would have got a Nobel Prize for that. Electrolysis, certainly another Nobel Prize. So at least 4 Nobel Prizes definitely would have got before he lived in the 20th century. Unfortunately, he lived in the 19th century where there were no Nobel Prizes. Faraday had 3 lessons for all of us. You, me, and everybody. And particularly those who are in science. Even they are not in science, every young student, every teacher. What was the one? Faraday was a stricter of everything. Very hard working. First of all, therefore, we should be hard working like Faraday. Every day of his life, he used to write everything he did in a beautiful handwriting. You go to London in the RAO institution, they are all really well maintained. You can see that. 1833, 24th December, exactly experiment he did. Then one day, 25th December is missing. 26th December, again for 25th December is missing because of the Christmas thing. One day it will come. That's how it was. And no student, no postdoctoral fellow, no government grant. He wrote 451 research papers, single-handed things. How many professors do that again? Anyway, more than that, he was a very simple man, very simple human being. He never wanted big, honors and all that, but he went on doing research, one thing after that. Well, I told them some stories yesterday. Well, I'll tell you how great he was. His simplicity was so great, he refused all kinds of honors. He just went on doing one thing after the other. Then somebody asked him, well, you go on publishing papers. Why is that? What is this science? Tell me what science is about. He said, I'm going to define science. Science is, in simple words, is following. Work, finish, and publish. Please remember all it. You see, we are scientists. Science is work, finish, and publish. Don't be shy about publishing anything you have done. Those who are shy about publishing, don't be shy about what they have done. If you are not shy about what you have done, you will not be shy to publish. So you have to publish good papers. That is one of the lessons of Faraday. I think many things that Faraday did continue to impress people like me. Even he did many things in life very great. That is also first one, I hope you remember, show the common basis for magnetism and electricity. The unification of forces in physics started with Faraday. So Faraday was one of the greatest minds. Because people think he was a physicist, actually he was a chemist, he was a professor of chemistry in London, and with only 3 years of schooling, maybe. So Faraday's life was an extraordinary life in that way. Well, we go on further. I just am trying to show you what all Faraday did: electrolysis, catalysis, discovery of benzene, magnetism. Yes, I can go on and on. And then I want to send you the story of a Russian. You see, we are still in the 19th century. Faraday died towards the 1860s, just past middle of 19th century. Again in 19th century was this man, the crazy Russian. 1834, 1907. That is the beginning of 20th century. So he came from a very, very poor family. When he was young, his father died. So he and his brother and his mother had no money. He felt that her son, Granddaddy, was very smart. He deserved a better education. So he takes her son, walks all the way for 1,500 kilometers from all the way from Siberia to Moscow by walk. And eventually reaches Moscow. There she doesn't get anything. Then she walks to St. Petersburg and eventually gets admission in the school. Somehow he studies, somehow he comes up. He is the one who came with the idea of a periodic table. The greatest table man has made is the periodic table. The periodic table has more information in one table than any other equivalent table man has created, and this man created. In fact, the story of Nobel Prizes, it starts here. In 1907, he could easily have got a Nobel Prize in 1906, right? So I want to know the story of Nobel Prizes now. I would tell you many of those. 1906, they decided to give a Nobel Prize for periodic table. Just as I was about to give the Nobel Committee, somebody went and said, some French people, you know, there are other French scientists who have just discovered the element chlorine. Why don't you give him the Nobel Prize? You can give him the mundane data. They said, okay, they have Moissan the Nobel Prize in 1906. After getting the Nobel Prize, Moissan dies. 1907, they would have given him, but before that, Mendeleev dies. So he died without the Nobel Prize. So to get Nobel Prize is that what? You should live very long. Second thing I forgot to tell you about Faraday. Faraday used to give lectures to young boys and girls like you every year, very popular lectures. The chemistry of a candle, very famous lecture of it. But what he used to do is he used to light a candle before his lecture. A standard candle in the old days, I don't know whether it's today, so burns exactly for 1 hour. At the end of his lecture, the candle would go off and he would stop the lecture. One of the rules they had was, no one had the right to bore others for more than 1 hour. And so, anyone who gives special classes for 2 hours and all, don't attend them in the school. After 1 hour, you get cut out. Any teacher gives more than 1 hour doesn't deserve to give a lecture. I believe in that. I believe you cannot absorb new ideas for more than 1 hour. Second, special classes at the end of the exam. Why didn't it be throughout the year? Why is second class at the end? Never attended second class. I never gave second class, never attended also. When I was a teacher, I never gave second class. After regular class, what day I will do? We teach them. Teach 1 hour, and then 1 hour is more than enough. You are really teaching. Anyway, Faraday was very particular, but nobody should lecture more than 1 hour. I agree with that. And it's very well known from psychologists that more than 1 hour, people can't absorb much. Well, I'm sorry, there was a teacher who did not agree with that. Well, chemistry, I told you, is a modern subject in many ways. In the 1st century, there were only 7 elements. And in the 18th century, when Lavoisier was there were actually 23, I don't know, I correctly there's not 20, 23. Today, of course, 114, actually now is 115 elements. So most of the elements you know only in the 20th century, so chemistry is really in that sense modern 20th century. Well, if somebody says we made jet planes in Ramana time, Very difficult because there was no aluminum, no titanium. Somebody says I made atom bombs during Mahabharata time. It's not possible. There was no uranium or plutonium. And the plutonium, by the way, was discovered by my teacher, Gilbert. He was a great teacher in Seaborn. And he got a Nobel Prize for that. And we then have to do it in atom bomb in India. There's no other way. But anyway, people shouldn't claim those things. Coming back, the elements, are all of 20th century. So that is the story of chemistry. And this is the periodic table I showed you, which has everything in it. The greatest man-made table. In fact, I gave a lecture in Sweden in some connection about 4 or 5 years ago. I showed them this is the greatest man-made table. And they all said, nobody ever talked like that about this. It is the correct thing. All human beings created. In one table you want to show everything. This table has a lot to show. And this is the periodic table that came out of the early studies of Mendeleev. But chemists make compounds, and the first compound was made by Bharat. It is a simple compound, urea. Urea is very important today because it is a fertilizer. He made it in 1828, early part of the 19th century. So you may say, what is so great about that? That is the first compound made. Not only that, there is a faith in the scientists of the world that no organic compound can ever be made in the laboratory. That was the belief. After all, organic comes from nature, so you need some vital forces of nature to make organic compound. You can never make it in the laboratory. So when we made the first compound in the laboratory, people didn't believe it. They said, how can you make it? It's an organic compound. You need vital forces. How do you do it in the lab? Absolutely no longer so. After he made many compounds, and he made like vitamin B12 or anything you think of, today we can make any compound in the laboratory. It is no longer a challenge. It becomes a routine matter. And this is Bharat, who made the first compound, whose statue can be seen in the center of Gilbert. These are all modern chemists. Gilbert is one of our modern organic chemists. But when, suppose you would ask me, just like in physics you can ask a question, similar question, modern chemistry of the kind we understand today, where did we start? The beginning of that, I would say we started it when we wrote a chemical bond as nothing but A between B, 2 electrons form a bond. This idea of the 2 electrons forming a bond came out of G.N. Lewis, a great scientist of the 20th century, who wrote the first paper on that in 1916. Next year, we are celebrating the 100th anniversary of the chemical bond. It's only 100 years, you know what a chemical bond is. We write all the structures today. Chemists think as if they are knowing all the time. No, no idea. So I told even our chemists in IITGuwahati, make a big symposium, big mathematics all over the world, celebrate the chemical bond 100 years anniversary. Because it's a great discovery, C.N.R. And this was given, described much better, much more by Ratna, who wrote the famous Nature of the Chemical Bond and dedicated it to G.N. Lewis. So the great names associated with the chemical bond are Lewis and Pauling. This is G.N. Lewis. I show him with a cigar because I always smoke a cigar. And in fact, in the University of California, Berkeley, which he built, he went there in the 1940s as a young man to build a department. He built such a great department. From 1946 till today, right today. The greatest chemistry department is University of California, Berkeley. Nobody can beat it. No Harvard, no MIT, no Cambridge. Nobody can beat the record of University of California, Berkeley chemistry. He built such a department. In fact, I was a postdoctoral fellow in that department many years ago, in 1957, 59. I tell you, the atmosphere, I could feel the ghost of Lewis. Lewis had died by the time. Everywhere it was Lewis. Lewis had created so many ideas in science, so many great things in science, that people never could. He would always smoking a cigar. When he was alive, people knew where the chemistry department was. All they had to do is go where the cigar smell was great. And this is young Linus Pauling. You see, I was showing all pictures of old fellows. I thought I was showing a young person with young wife. This is young Linus Pauling, who started working in chemical bond with his wife, he started working on, he was a young man at the age of 25, 26. He wrote his most famous paper at the age of 25 or 26. After that, he is the one who started making a science of chemical bond. He wrote the famous book, Nature of the Chemical Bond, for which he got a Nobel Prize later. But the idea that electrons related to chemical bond was first given by C.N.R. Lewis, as I told you before. Now, I don't want to go through that, but here is another story of Nobel Prizes. 1 minute on that. Lewis did so many things. He is the one who gave the idea of a chemical bond. He is the one who wrote the first book on chemical thermodynamics, that is the free energy of substance. He is the one who gave the first law of thermodynamics correctly. He is the one, therefore, chemical thermodynamics, he should have gotten Nobel Prize. He was nominated 20 times for that, for Nobel Prize. He didn't get it. He was nominated another 10 times for chemical bond. They said, we are not sure chemical bond is such an important thing for chemistry, they said. They didn't use it. Amazing. And then he discovered Lewis acid, Lewis bases. Everyone talked about it. Then they said, oh, we are not sure Lewis acids and Lewis bases will be so important to chemistry. They didn't give Nobel Prize. Then he started working on heavy water. I hope you know, heavy water is G2O. The element deuterium was discovered by one of the students of C.N.R. Lewis, Lewis. When he discovered deuterium, Lewis said, what do you use of an element? I make a compound, we made D2O. With the laboratory. And D2O is application in various things, spectroscopy, thermodynamics, in biological systems. We published a lot of papers on that. So eventually when the Nobel Prize was given, they only gave the deuterium element, not Lewis didn't get the Nobel Prize for D2O. So it's one of the sad stories where a great man with so many new ideas and revolutionary quantum chemistry, 20th century, didn't get a Nobel Prize. So you must be prepared not to get a Nobel Prize. See, so you're always great friend like that. Now, don't take the Nobel Prize. If he cannot get it, nobody else has the right to expect the Nobel Prize. It is such a sad story. In fact, the electron was discovered in 1997. 2 years later, he wrote a paper, the relation between electrons and chemical bond. Unfortunately, the professor when they moved his work, he said, oh, it's all rubbish, nonsense. So he couldn't publish it. He waited till 1916 to publish it when he became a professor. He is a very extraordinary genius, C.N.R. Lewis, and the greatest tribute to him, one of the greatest chemists that ever existed in 20th century. And after the now, this year, I want to quickly picture you how chemistry changed. See, when once chemical bond became famous, structure of molecules became understood, entire chemistry was dominated by structure, reaction mechanism, all kinds of things, use spectroscopic methods, use diffraction methods. And it is at that time in 1951, Linus Pauling discovered the structure of the alpha helix. And then they went to molecular biology. See, here is chemistry is the mother of molecular biology. In fact, one of the first molecular biologists was Linus Pauling himself. And Linus Pauling discovered the alpha helix in 1951. And of course, this is the Linus Pauling, he got a first Nobel Prize in 1954 for the chemical bond after he discovered the structure of the alpha helix. And of course, chemistry in 1950s and 60s, when I used to teach in IIT Kanpur, we used to say chemistry involves structure, dynamics, and synthesis. Chemistry was described mainly based on structure of molecule. However, things change. Now, that is the thing about nature of science. I want you to know. Today's science will not be tomorrow's science. Today is very valuable. Every day it keeps changing. To do good science today, you have to be prepared for tomorrow. It is not tomorrow you have to prepare, today itself you should know what is going to be tomorrow. Otherwise, you take it to good science today. That is the problem we are facing in India. Many people do not realize that. They go on doing what was done yesterday. Therefore, nobody looks at it. See? Yesterday's science is over. Finished. You do it, but I can go on writing 50 papers, and nobody reads that. You must create science of tomorrow. That's why you are all here today. Think about new ideas and create science, engineering, everything of tomorrow. That is the thing. And what is science of tomorrow? I don't know. Then what happened in science? Then about 20 years ago, suddenly biology started entering chemistry in a big way. And then advanced materials started entering in a big way. So today what has happened? Chemistry has only two major streams. One is biological oriented chemistry, another is advanced material oriented chemistry. The rest of chemistry, many others do it. You can do it, it is not so important. I'm not against those who do it, but they won't make a big, they won't have a big story to solve. But you see, great and material, high temperature superconductivity, carbon, nanoform, so many new things started coming after the 70s. the subject of chemistry changes because of materials, change because of molecular biology. And then all kinds of new ideas like supramolecular chemistry, weak interaction, forming all kinds of assemblies, self-assemblies. All this has started. I've just shown you what is superconductivity, just what happened in superconductivity. In 1986 December, it's actually a real story in my life. I was in a big conference in Bangalore in Ratna Hotel. There was a very famous Nobel laureate, Gilbert in physics, who gave a lecture. In fact, I gave a lecture on valence fluctuation in chemistry. Soon after his lecture, I followed his lecture. After my lecture, he came running, Professor RAO, do you know the high-temperature superconductor has been discovered? A new material which is superconducting at 25 Kelvin. What? I said, I just wrote a review saying there is nothing above 23 Kelvin. 23 Kelvin was the limit, whatever man did. No, it is not 35 Kelvin. Somebody in Switzerland has found. And in what material, I asked Phil Anderson. He said, no, it is an oxide. And that oxide, I think, the kind you have been working on. Well, you know, in fact, there was a lanthanum, something is it lanthanum, copper, something. You mean is it lanthanum? I don't know, let me tell you, is it lanthanum, copper? I said, yes, that's it, he said. He said, I'm repeating exactly what happened in my room. Then he said, I want to show Steve what all we have done in this field. So he came to my lab, it was around 6 in the evening. We worked till about 9:30 that night in my lab. I showed my papers on lanthanum copper oxide. I've already shown it to the antiferromagnetic. Unfortunately, nobody had seen that. But I had already shown in Kanpur IIT. Unfortunately, in Kanpur IIT, we had no liquid helium facility. In some of my samples, would have got superconducting at program. I didn't have, there is no way to measure. But we had done the basic thing. But then, that phase is over. And then the people who discovered this, the 35 Kelvin superconductivity, got a Nobel Prize. And then everybody wanted to do superconductivity higher temperature. Liquid, 35 Kelvin is still require liquid helium, you see. But you need liquid nitrogen, which is the cheaper liquid to have. So everybody was looking at liquid nitrogen superconductor, America, everybody, and we started doing the same thing in Bangalore. And it was eventually found the first liquid nitrogen superconductor is 123, 1 yttrium, 2 barium, 3 copper. It is popularly called as 123 compound. YBM discovered in Bangalore. We published in Nature in March 1987, 90 Kelvin superconductor. Of course, we did at the same time as Bell Labs and Chinese, doesn't matter. So it was a very wonderful, thrilling moment for me. I still remember that morning, early morning, we were working here. I went there to the lab to early morning, driving my own car. But what happened? No, I found this transition, he said. Showed me that, it was a very thrilling moment. Immediately I started writing this communication from Nature. It was one of those great moments. So this is the first liquid nitrogen superconductor. Since then, chemists have made all kinds of compounds which are superconducting. The reason this is important is, after the discovery of superconductivity in 1986-87, chemistry became a major part of modern material science. In fact, there is a beautiful report of the US National Academy of Sciences where it says, chemistry became a major component of modern material science because of the contribution they made to superconductivity, superconducting material. Today, of course, without chemistry, you can't do very much material science. It doesn't matter what you are doing, you need a lot of chemistry in that. And of course, there was a fullerene discovery in 1985, 1990, the C60, C70. Carbon nanotubes were discovered in 1990, 91, so many things. So today, a new thing has happened. Molecules which form the basis of chemistry and basis of everything till now, in the 2000 and on, the last 10 years or so, we have gone beyond the molecular frontier. As a beautiful report of the US National Academy says, we now work on chemistry of life, chemistry of living systems, chemical therapies, optimization as a biological system, the so-called synthetic biology, doing chemistry through biological processes, new kinds of synthesis, complex chemistry, complex chemistry of the earth, sea, and the atmosphere, materials by design, computation at very high level, and so on. So chemistry has completely changed. This is the only story of chemistry. A similar story can be told of physics as well. A similar story can be told of many other subjects. I want to take an example of chemistry, how science changes, how science keeps changing. In fact, as one of my friends long ago said, you have to be galloping in science today to remain stationary. That's absolutely correct. We have to really working hard to do contributions of there. And that's why we need young people like you. So you can start galloping now, remain stationary, then suddenly maybe you will win development prize. Now, what are the things that we should be doing today? You know, a lot of young people ask me, sir, what research should I do? Oh my God, there are so many problems to do. Why are you looking for it? For example, take one problem, energy and environment. This is, I think, the most crucial problem of mankind. Everything is related to energy and environment. You have pollution, your water management is so bad, everything is bad. You look at that environment in India, is one of the worst. It's impossible to breathe the air in Bangalore. It is so many particles and so much of dirt and so much of everything that you don't want. Same in Delhi. Delhi is next to Beijing now. Beijing, you cannot believe it. I was in Beijing a couple of years ago. Everything was surrounded by this fog. I didn't know where I was. In fact, one day suddenly, the fog cleared. I found in front of me there was a huge building. My God, I didn't know there was a building there. I didn't know whether. In fact, I could see several hundred yards. You cannot see more than 100 yards. 100 yards, you are lucky in a bad day in Beijing. It's terrible. If you want to live in the world of that kind, that is one aspect of pollution. There are other aspects about atmospherics, about rain, monsoon, everything is related to environment. Energy, you know, I hope you all know that. Let me tell you this story. It is very important in a lecture like this. I'll take only 5 minutes more, 7 minutes more. I will do 1 hour, so 7 minutes more. So, energy, I hope you all know that. You should know these numbers. India's requirement is about 400,000 megawatts of electricity. Some people even say 600,000, 800,000. I'm going to make a slightly lower, 400, maybe 300,000 megawatts. Well, how do you get this energy? Well, if you are using a lot of oil for burning for cars and automobiles and planes, you have lost all of that. Maybe you should use it maybe to make chemicals and drugs and pharmaceuticals. Then what about electricity? How do you get that? It's a very serious problem. And now, people say, oh, nuclear, we do nuclear. Well, you know, I know nuclear very well. If you are lucky, you will make 30,000 megawatts in another 10, 15 years. Very important. So it won't even account for 10% of our requirements. So you have to require photovoltaics. Photovoltaics is good. Where you use sun's energy, convert the electricity. Now it becomes very easy, cheap. Silicon cells are very cheap. Chinese are dumping solar cells in India. In America, China, Japan. In America, you got acres and acres of land are used for solar cells which are converting solar energy into electricity. We should start doing that. Unfortunately, we have not even reached 2,000 megawatts of solar photovoltaic in India. I think we should reach at least 20,000, 30,000 megawatts, at least in the next 5 10 years. I hope we do that. So it will account for the 8% of our requirement. So the future energy, according to hydrogen, solar, fuel cells, batteries of various kinds, all kinds of catalysis. And hydrogen is very important, particularly I am showing artificial photosynthesis. I hope you will know photosynthesis, what plants do, take sunlight, break up water into oxygen and hydrogen. In fact, oxygen is what you breathe, because that water gets split by the water oxidation complex. And what happens is the electron gets oxidized, gets excited in the photosystem too. Then that pulls out an electron from water oxidation complex, which then pulls out an electron from water, and the water gets oxidized, gives you oxygen, which you can breathe. And the other excitation electron in the photosystem, one is the one that reduces, gives you food and all that. Instead of doing that, getting food, you can get hydrogen by reducing water. And that is the one, and America has now declared that will be the national mission for energy in America. I think in high time we work on this area of research that I am working on for the last 2-3 years with fair amount of success. I wanted to see a word story. How in 1874, Jules Verne in Mysterious Island wrote this. What will the burn instead of coal? Asked Pencroff. Water, replied Darwin. But water decomposed into its primitive elements. Yes, my friends, I believe that water will one day be employed as fuel. That hydrogen and oxygen, which constitute it, will furnish an inexhaustible source of heat and light. Water will be the coal of the future. It was written in 1874. But we forgot about that. People even wrote how solar energy is used, but we have not used it. Okay, hydrogen I think become very important, and I think we should do something in the area of hydrogen. I would like to close the lecture now. Well, I asked this question, what did you do yesterday? With science, there's no yesterday and tomorrow. You do every day. I told you about Faraday, how he worked every day. You need constant vision. Yesterday's plate is stale. You need new food in science. You need to have passion to do that, and we need that very badly. We need in India people who work hard, who work for tomorrow, and who keep working all the time. The great scientists of the past, many of them did that. I only gave Faraday's example, and there are many other stories I can talk about. Well, one of the most important things to remember is that we have to be hardworking, we have to be more selfless, we have to keep working as long as we can. And in fact, I can never forget many stories, but I keep telling you it will take more time, so I will not do that. But I will say, I'll tell you one thing that is very important. The most important quality required for success in India or success in science, both are the same. If India's future is based on science and technology, then we have to work very hard for new types of science and technology that will make India competitive with the rest of the world. There is no point doing something that is mediocre. We should be as good as the Americans and the Chinese and the Koreans. If we have to do that, I'm afraid we have to way too much harder. We all have to give much more time, much more energy. To do that, we have very few time, and we have to do that fast. Well, as I was telling you yesterday, my own life, I've had a wonderful life. I've been working for the last 60 years. Actually, I started doing research in science exactly 64 years ago. My first publication was about 61 years ago, research publication. I'm still publishing. I'm now 82 years old, in my 82nd year. I still publish 20-25 papers a year, and I go on doing that. And it's been a wonderful life. I don't think you can have a better life. I always challenge people. You know, if somebody asked me in a TV interview recently, suppose you have to do it all over again, what will you do? I will do exactly what I have done, and no regrets. I don't have one people life, happy life. As far as I know, I don't have anybody who is as happy as I am. I have a wonderful life, and a wonderful happy life. This happiness came because I have no other worry. I don't worry about money, I don't worry about this, that, and so on. I worry about what doing science. And then working with young people like you. The greatest pleasure is when I see young faces and with bright eyes. And my great teachers, as J.C. Ghosh always used to say, the bright eyes of my Bengali children are the ones that inspire me. Always used to say, bright eyes of my Indian children are the ones that inspire me. And don't forget, and I would like to post, I would like this world not to be forgotten. I always, I'm a great admirer of Bengali culture, Bengali Renaissance, particularly of Tagore in one of the poems says, let us not forget, when, time to say goodbye, let us not forget, this world has done so much for me, I have not done enough for this world. I feel the same way about science. Science has done so much for me, I have done so little for science. Thank you so much.